So once again, just reviewing inverses, we start with the function 2x minus 4. And remember, to find an inverse, we would switch the x and the y, and then solve for y. So divide by 2, we solve that for y. And so we got our inverse here of 1/2 x plus 2, if we wrote that in y equals mx plus b form. And remember that notation, remember that f negative 1, remember that negative 1 is not an exponent. That's not an exponent. It just means inverse. And then once again, just reviewing here, if we look at the original function and if I graph it, it looks like this. And then remember, for the inverse, well, I have an equation I could just graph. I could graph that equation. Or I can also look at these points on the original function and just switch them. Switch the x and the y. Instead of 0, negative 4, that'll be negative 4, 0. Instead of 2, 0, this will be 0, 2. But that'll also be that equation y equals 1/2 x plus, whoops, how about plus 2? Get the equation right there. 4 over 2, so y equals 1/2 x plus 2. So these are inverses of each other. And remember also that they're reflections over that line y equals x. And also remember that how to verify or how to show that these are inverses of each other, you do the composition. Remember, we could do the composition of the function and the inverse of f of x. And if those are inverse each other, or just to verify they're inverses of each other, that would just equal x. And since composition of functions is not commutative, we would show this also, switch the order, just to show that they're inverses of each other. Let's see, what else with inverses? If we had f of 1 equals 2, well, this is our domain. Our x value is our domain, and then this is our range. And then if we take the inverse, so if we did the inverse of 2, that would give us 1. That would give us the value 1. This is now our domain, and this is our range. Remember, it's sort of we switch the x and the y values, and we switch the domain and the range. So let's see another way to look at this. If we look at this, if I look at the set just containing 1, the set containing 2, my original function here is going to take 2 and assign it to 1. It's going to take 1 and pair it with 2. This is my domain, and this is my range. The inverse then sort of undoes that. The inverse is going to undo that. And now the 1 is for the inverse is my range, and the 2 is my domain. So just sort of another way to think of that. Basically, we're switching the x and the y, and so the domain and the range are going to switch. Remember, the domain is the values you're going to plug into the function, and then the range is basically the answer that you're going to get out. Also remember that the only kind of function to have an inverse is a one-to-one function. So let's see, I'm going to look at this again here. If I just look at this line, first of all, I know it's a function because it passes my vertical line test. And then to check to see if it's a one-to-one function, we're going to do the horizontal line test. And this one passes, so this does have an inverse. But very important here that only one-to-one functions have inverse functions. Very important. Only one-to-one functions have inverse functions. And to see if it's a one-to-one function, you do your horizontal line test. So once again, just reviewing functions. Pretty much everything we know about functions. Well, what does that have to do with trig functions then, and inverse trig functions? Well, let's take a look at that. Let's start with sine. And if we look at sine, I'm going to go ahead and let's go ahead and graph. I'm just going to graph the sine function here, just real sort of quickly here. I'm going to go ahead and do a little bit more there. So if we graph the sine function, well, first of all, it is a function. It does pass the vertical line test. But do you see how it's not a one-to-one function? It does not pass our horizontal line test. So it's not a one-to-one function. So it's technically, it cannot have an inverse. It cannot have an inverse function. The way it sits like this, looking at this, it cannot have an inverse function. But if we artificially restrict the domain, we're going to, instead of looking at the whole graph, we're just going to look at a part of the graph. If we would just look at the part of the graph from negative pi over 2 to pi over 2. So if we restricted the domain to just negative pi over 2 to pi over 2, do you see how now that would be a one-to-one function? So let's restrict the domain to negative pi over 2 to pi over 2. So we're gonna sort of artificially restrict the domain. The notation that we're going to use now, because now this would be a one-to-one function. If we only look from negative pi over 2 to pi over 2, will be our domain. Our range is still going to be from negative 1 to 1. But this sine function on this domain is going to be a one-to-one function, so it will have an inverse. So the notation that we're going to use for that is the same as we did before, but you're going to put sine with that negative 1. And once again, not an exponent. That's not an exponent. It just means inverse. It's not an exponent. And let's see. Or those are two different ways you can write the inverse. You can either write sine negative 1 of x or arc sine, A-R-C, arc sine of x. These are used interchangeably. They mean exactly the same thing. So if we look at our function here, I'm just going to look at y equals sine of x again. Well, we're going to only look at the domain here. From negative pi over 2 to pi over 2. our range, our possible values we're going to get is going to be from -1 to 1. Oops. So you can see that. Well, now let's switch it around and let's look at the inverse function. If I look at the inverse function, well, the values we can put in here, our domain of our inverse function, now remember that's going to be the same as our range of the original function. So for the inverse function, our domain is going to be from -1 to 1. So the values you're going to be allowed to put in here, put in for the x values of the inverse function, are going to be from -1 to 1. There we go. And then our y values, our range or our answers here, well, those can only be from -π/2 to π/2. So our possible answers, if they ask me for the inverse sign of something, my possible answers have to be numbers between -π/2 and π/2. Or let's see, if I take that to a decimal, it's -1.57 to about 1.57. You know, if we have not exact values, if we take that to a decimal. So let's, let me look at an example of that. If they ask me the inverse sign of 1/2. If they ask me for the inverse sign of 1/5, they're really asking me here where on the interval from -π/2 to π/2 is the sign equal to 1/2. So that's what they're really asking me. When they ask for me for the inverse sign of 1/2, they're asking me where on the interval from -π/2 to π/2 is the sine function equal to 1/2. So we think about our unit circle. The sine's equal to 1/2 at π/6 and also at 5π/6. But they don't want those answers. I mean, there's an infinite number of answers to just where is the sine equal to 1/2. We could just keep going around and around the unit circle to get an infinite number of answers. But we want only the answers between -π/2 and π/2. So only here, only between -π/2 and π/2. So our answer here is going to be π/6. So we have to be able to just get one answer, π/6, or approximately 0.5236. If we wrote that as a decimal, which would be about 3.14 divided by 6. Well, let's look at another trig function. That was the sine. Let's look at cosine now. And if we look at cosine first, let's sketch the graph of cosine. Let's do our 5 key points. Let's see, I did sine a little bit longer, so I'll do cosine a little bit farther too. Well, once again, cosine is a function. It passes our vertical line test, but it is not a one-to-one function. It does not pass our horizontal line test. So in order for this to have an inverse, we have to restrict the domain. Well, let's see if -π/2 to π/2 works again, because that worked for sine. If I go from just -π/2 to π/2 No, that is not going to work, because that is not going to pass my horizontal line test. It would be so much easier if these all just, we could keep the same interval, but that doesn't work. Well, let's go to the right then. What if we go from 0 to pi? Do you see how from 0 to pi, now this is going to be a one-to-one function. It's going to pass our horizontal line test. So now we can restrict the domain 0 to pi. We'll just restrict that domain from 0 to pi so we can have an inverse. So, and this is just to have an inverse here. So if we, let's summarize that here. If we have y equals cosine of x, well, we are going to restrict the domain, the values that we can put in here. We're going to restrict those to 0 to pi. The y values, our range, well, those are going to go from -1 to 1. And we're only going to look at sine, cosine, and tangent. We're not going to do inverses with the other ones right now. So then if we look at the inverse function, so that's the regular function. We're going to restrict the domain so that we can have an inverse. So it'll be a one-to-one function. So then the inverse function, cosine, the inverse function, well, the number we put into the function is our domain. And the number we put in, remember, we're going to switch the domain and the range. We're going to switch those for the inverse. So the domain, the number that we can put in is going to be between -1 and 1. So we're going to take the inverse cosine of any number here between -1 and 1. And that equals our range now. Our answers here, or our range, have to be from 0 to pi. Once again, we just switched the domain and the range for the inverse function. Now the range is going to be from 0 to pi, or from 0 to about 3.14. So your answer has to be a number between 0 and pi, or between 0 and 3.14. So let's see, if we look at an example of this, let's say we did the, I'm going to use arc here. Arc cosine of 1/2 equals question mark. That's what I want to know. I want to know, what is the arc cosine of 1/2? So basically that's asking me where on the interval from 0 to pi is the cosine equal to 1/2. That's what that's asking me. The arc cosine of 1/2, it's saying where on the interval from 0 to pi is the cosine equal to 1/2. So if we think about our unit circle, cosine is 1/2, let's see, here and here, at pi over 3 and at 5 pi over 3 is where the cosine is 1/2. But our answer for cosine has to be between 0 and pi. So the only one there between 0 and pi is pi over 3. Or a not exact answer, but if we did 3.14 divided by 3, let's see, that would give us about 1.0472. Just if we took this to a decimal. This is an exact answer. This is how most of the time we'll leave it, but I also want you to think, well, pi over 3 is just the same thing as approximately 1.0472. Any questions so far on sine or cosine inverses? Okay, good. Well, let's look at one more, and that'll be the tangent. So tangent, we're going to look at the graph of tangent. Put in my asymptotes at negative pi over 2 and pi over 2 and 3 pi over 2. And once again, I just did a quick graph of tangent here. And we want to, first of all, look at this, and it is a function. It does pass our vertical line test. It is not a one-to-one function. It does not pass our horizontal line test. We even just put two parts into it, 2 periods, but this keeps going infinitely to the left, infinite to the right. So this is not a one-to-one function. So we've got to see, well, how can we restrict the domain? Well, we really could do, 0 to pi, but that's a little awkward because we have up here and then down here. They have decided to restrict this the same as sine, sort of from negative pi over 2 to pi over 2. So you see how this is now a one-to-one function. It's going to pass our horizontal line test. So we're going to restrict the domain. And the only thing is for sine, I used brackets because we included negative pi over 2 and pi over 2. But do you see how tangent, we're not going to include those because they're asymptotes. There's no values at negative pi over 2 or pi over 2. That's where it is undefined. So I'm going to use parentheses, negative pi over 2 to pi over 2. So let's look at this. We have y equals tangent of x. So if we look at these, the y value is our range. So our range for tangent, this is different. This is all real numbers, negative infinity to infinity. We can put any real number is going to be our range for tangent. And for our domain, in order to have an inverse, we have to artificially restrict that. We have to restrict that from negative pi over 2 to pi over 2. So we're restricting the domain. So then for the inverse, inverse tangent or arctangent, the numbers we can put in here in our inverse function, our domain for the inverse function, well, that's going to be any real number, negative infinity to positive infinity. And then for the range, or our answer, like for our inverse function, our range, all the answers have to be between negative pi over 2 and pi over 2. Or, I guess I could say negative 1.57 to 1.57 if we took that to a decimal. So if we look at an example problem, if they asked what's the arctangent of 1, or inverse tangent of 1, mean exactly the same thing. Those are exactly the same question. And what this question is asking, it says where on the interval from negative pi over 2 to pi over 2 is the tangent function equal to 1. So that's what that's mean. It says where on the interval from negative pi over 2 to pi over 2 is the tangent equal to 1. So then this is why I had you do this last night. So last night you said, well, the tangent is 1 at pi over 4 and at 5 pi over 4. Once again, that's what you did last night. We got two values from 0 to 2 pi. But now our inverse can only be one answer, and it has to be from negative pi over 2 to pi over 2. So the inverse tangent, or the arc tangent, would be equal to pi over 4. Or you have 3.14 divided by 4 if you get a decimal approximate answer. Let's see, what is that? That's about 0.7854. Today we're going to mainly be working with exact values, but I just don't want you to lose sight of the fact that pi is just a value. It's just a number. It's an irrational number, but it's just a number. It's not a variable. It's, you know, we could take that to an approximate decimal. Okay, well, those are our functions, and let's see if I just summarize this real quickly. The inverse sign, the domain is the same as the range of the original, so that's from -1 to 1. And then remember, for sine, the inverse sign or the arc sign, that has to be from negative pi over 2 to pi over 2. And you have to know that. All your answers have to be from negative pi over 2 to pi over 2. And the inverse cosine, once again, the domain here is going to be from -1 to 1. And then the range, or our answers, have to be from 0 to pi. For tangent, the domain, the numbers that you can plug in here are all real numbers. And the answers, or our range, have to be from negative pi over 2 to pi over 2. And I'm going to use parentheses there because we can't include those. So let's look at let me just look at a few example problems. Let's see, how am I on time? Good. Yeah, good. So examples, inverse sine is 1/2. So once again, that's asking you where on the unit circle is the sine equal to 1/2. Well, there's two places, but this is saying, you know, where on the interval from negative pi over 2 to pi over 2. So this would be pi over 6. Or approximately 0.5236 if we took it to a decimal. But we're going to keep this exact. And then this is an approximate. Not a bad value, just an approximate. We had to round it. And if we look at another one, arc cosine is 1/2. So where on the unit circle is the cosine equal to 1/2? Well, once again, this is what you did last night here. Let's see, that would be pi over 3 or 5 pi over 3. But the arc cosine is asking you where on the interval from 0 to pi is the cosine equal to 1/2. So from 0 to pi, so that would equal pi over 3. Or approximately, let's see, 3.14 divided by 3, approximately 1 point, if we took that, you know, if we did 3.14 divided by 3. Well, this is the one I really want to look at. This one's a little bit different here. Arc sine of -1/2. The procedure is still the same. Where is the sine on the interval from negative pi over 2 to pi over 2 equal to -1/2? Well, let's see, that would be here and here. That's 7 pi over 6 and 11 pi over 6. And we're looking for values from negative pi over 2 to pi over 2. So we're looking for values between here and here. And you're like, well, okay, I'm just going to put 11 pi over 6. The only thing is 11 pi over 6 is not a value between negative pi over 2 and pi over 2. It's not between negative 1.57 and 1.57. 11 pi over 6 can also be written, let's go in a negative direction. That also can be written, that's the same thing as negative pi over 6. Now that number is between negative pi over 2 and pi over 2. So it's the same location, we just can't write it like that because we cannot have a number that's not between. All our numbers that we write down have to be between negative pi over 2 and pi over 2, or between negative 1.57 and 1.57. So this would be negative pi over 6, or negative 0.5236. So that's on the interval. That's between negative pi over 2 and pi over 2, or that's a number between negative 1.57 and 1.57. So that's probably the toughest thing, to make sure you have to write this answer. What you write down there, it can't be equivalent to it. It has to be an answer. It has to be a number that's actually between negative pi over 2 and pi over 2. It can't just be in the right location. It has to be a number that's actually between negative pi over 2 and pi over 2. And let's do one more. Inverse sine of 1. So where on the interval from negative pi over 2 to pi over 2 is the sine equal to 1? So the y-coordinate will up just one place. Right? There's only one place where the sine is equal to 1. And is that on the interval from negative pi over 2 to pi over 2? Yep, it sure is. We included it there, so this just equals pi over 2. We just have one answer, and that's our answer, pi over 2, or approximately 1.57. If we took 3.14 divided by 2. But once again, we're going to leave all of our answers exact. Your homework then is going to be a maze. And here's what it looks like on Google Classroom. You are going to take and you're going to drag the circle over to the problem. So here we'll start right here. So I also want you to do this on a separate sheet of paper. I want you to take, here's what the maze looks like here then. And you're going to do problem number 1. So I want you to write this down on a piece of paper. So you're going to start off here with number 1. And you're going to write arc cosine of radical 3 over 2. And then I think it's really helpful to either look at the unit circle, or even probably more helpful or just more good practice for you to sketch the unit circle and think, okay, well, where on the interval from 0 to pi is the cosine equal to radical 3 over 2? Well, I'm going to just do both the places like you did last night, at pi over 6 or at 11 pi over 6, just like you did last night. Well, then we're just going to narrow it down. We're just going to look at the interval from 0 to pi. And so that's going to give us pi over 6 would be our answer. And so that's when you're going to go to your maze and you're going to say, okay, well, it's going to go this way. So this was my first problem. I'm going to go this way. So now I'm going to circle. This is my second problem. So then you're going to go number 2, tangent -1 of 0. So now you're going to ask yourself, well, where is the tangent equal to 0? Where on the interval from negative pi over 2 to pi over 2? Well, I'm just going to do all the places here where tangent is equal to 0. Well, let's see, tangent is y over x. So let's see, that's going to be here at 1, 0, at 0, and here, let's see, -1, 0. Both of those places, the tangent's going to equal 0. But once again, my answer, my one answer, has to be from -pi/2 to pi/2. So our answer is going to have to be 0. And then you're going to go this way. So then your third problem is going to be the inverse sine of -1. And I'm not going to do your whole worksheet here for you. I'll go ahead and let you go from there. But this is your homework then, is to finish this maze. So finish it on Google Slides and also write it down. I want you just to practice writing this. I want you to practice writing the notation. If it's helpful, I really highly recommend sketching, the unit circle. Just a very good practice and very visual. But then just take a picture of that and submit that. I also included more formal notes that we'll go over tomorrow, some more formal notes, and the worksheet we're going to do tomorrow, just in case you have a printer and can print that off or to look at it. That's why I included those a day ahead of time for you. But any questions on the inverse?